welcome all to the first session after the lunch break. So I will talk now together with my colleague Monika Balk about antenna placement and installed antenna performance. And so first I will give a short outline of the following talk. I will start with the antenna placement in CST Studio Suite, and we will see here the differences about the single solver approach and the hybrid solver approach. And then we will talk about the array installed performance. So we will again see here the array from my last talk that will be placed on a mast. And again, I will do a short live demonstration in CST Studio Suite. And after that, I will hand over to Monika, and she will give an insight about the collaborative antenna placement in the 3D experience platform. So then let's start with the topic antenna placement, and here we can distinguish between two simulation options that we have. So the first one that we see here is the full wave single solver approach. We take the antenna, place it on a platform and run the simulation in one single solver. And the problem here is, you can see it in this example. We have here a monopole antenna placed on a very large ship, and the electrical size is here critical because this will lead to a very big simulation domain and high mesh number. And this could lead to some problems that the simulation cannot run on a single machine. And this will lead us to the multiple solver approach here, so the hybrid simulation. The difference is here we calculate the fields of our source, or the antenna. We can calculate the near field or far field. That depends what you want to do. And then we place these fields to the platform simulation project. And we can use for both simulation types different solvers. So for example, for the antenna simulation, we stay with the time domain solver. And for the large objects, we go with one of our surface mesh based solver solutions for the, for example, integral or asymptotic solver. Then the question is, what do we get from this simulation? So we are in general interested in antenna placement characteristics. So how will the antenna work in the environment later on? So if it is placed, for example, here on an aircraft or on a ship. And the other thing we are interested in is the antenna-to-antenna coupling, which is given by the S-parameter coupling matrix here in this case. And if we go with the single solver approach, we get both information. There is we do not need to consider if which solver we have to use here, or the setup is equal to a standalone antenna simulation. And for the hybrid solver approach, the question is, what do we want to calculate? For the placement question, it is often sufficient to go with a unidirectional, so we calculate just the field of the antenna and place it then on the platform in without any backscattering that is considered from the platform. Or we can go with the bidirectional approach. So there we can iterate between the source and the platform project, which will at the end show us the coupling as an S-parameter matrix. So here we see again the antenna array from the last talk, and then we talk about the